So in this video we are going to look at both the law of sines and of cosines. So we'll do a little bit of review of just the formulas, not how they were derived in order to solve some of the homework problems. In this first instance, we see that there is a pair of a side and an angle that are across from one another that have their measurements that match. And there is another side and another that match, and we are missing both the degree measure of this y and the side length of this side x. Okay, so in order to find y, I would suggest that into a calculator we just find what would add up to 180 in this instance if we were to add all three interior angles of that triangle. So go ahead and do that on your calculator real quick, and we'll move on. Once you have that angle measure, go ahead and add it to your drawing on your worksheet. It is 107 degrees is the measure. So the law that we're going to use to find this missing side x is going to be the law of sines. If we flash back to last week, we had the formula of sine of angle A over measurement of side A is equal to sine of angle B over measurement of side B. And that also corresponds to what we know about C. This is the formula to use for the law of sines. So we have to find those two things that match. Let's use sine of 31 over 7 for our first setup, since those are across from one another. Sine of angle measure 31 over 7 is equal to, and we will use this measure right here of sine of 107, and we will put it over this mysterious x that we're trying to solve for. In the recommendations of Mr. Dudat, we would use cross multiplication to do this solving, and that would involve typing into your calculator 7 times sine of 107 degrees. So that was 7 multiplied by sine of 107 divided by sine of 31. Excuse me. So then you divide by sine of 31. Into the calculator, that looks like this input. Check yourself and see what you generate as a length measure for side x. Do double check that you are in degree mode and not radian mode. That will help you. It should be a number that is larger than both the 7 and the 9.1, although to be fair, not all of these triangles are to scale on this homework. To review, we know that when we'll be using, we'll be using the law of sines when we have triangles that are set up such that there is a matching pair of angle to opposing side length that exists, and we can derive one other part that matches like that. So if you can make that type of two crosses in a triangle, then you're going to be using law of sines. Now let me go ahead and demo one that would be using the law of cosines. Okay, if you have not watched Mr. Dudat's Ed Puzzle, then you probably haven't looked at the equation that is used for law of cosines, but we'll stop and take notes about it right here, right now. So the formula is c squared, this is a side, go ahead and label it in your notes that it's a side and not an angle measure. C squared equals a squared plus b squared minus 2 times a times b times the cosine of angle measure C. This is going to be a side. This is a different side across from angle A, a different side. And these are all sides. This is a side measure, and this is an angle measure. Go ahead and label that in your notes, that the lowercase letters indicate side lengths and the uppercase letters indicating an angle. Okay. In this situation, what you are looking for is the side across from 76 degrees. We'll call this C. It's the unknown question mark. This one can be A, this one can be B. We could swap them, no big deal. Let's label them that for right now. Okay, so what we're going to be doing is we're going to just do a little bit of plug and chug, matching these variables to the places where they need to be in this equation for the law of cosines. So, C squared is going to be equal to A squared, which is 6 squared, okay, plus B squared, which is 17 squared, minus 2 times those sides, again, repeated, 6 and 17, times cosine of this angle right here, uppercase C, 76. Literally what you're going to do is take all this jazz right here and throw it into your calculator. When you have input all that, you'll get an answer, an ants, according to Texas Instruments. After that, hit second x squared to get that square root sign. To do that, you hit second plus x squared at the same time to get that, and then put the answer in here by hitting second negative sign. Hopefully you see that on your Texas Instruments. I don't have a way to model that. I don't have the calculator downloaded on my screen to show you. But you should be able to find this side length by doing this formula here. That's going to work every time for law of cosines. And the triangles that are like that have a known side, an angle in the middle like an elbow, and another known side. That's kind of one of the clues that you're going to use law of cosines. The other clue would be when you're given all the side length measures but none of the angles. Something like that would also be a time when you're using law of cosines. Hopefully this is helpful for you to refer back to. I haven't done a step card video in a while, but reach out to me if you have any questions.